Okay, hello class. Welcome to lesson 2. Working on quadratic functions and developing plans to model and solve problems. And so the big difference here is we're actually going to be looking at situations where we actually have to create the equation ourselves. And so, but we're still going to step back, and the modeling is actually going to be a skill in itself. But we're just going to step back and ask ourselves, like, what do we have? What form could we potentially make, and what do we need to do to get to solve the problem? And so, like, what right now again is we're just looking at the plans, solving the problems. But notice that the learning goal is different. It's modeling situations using an algebraic representation and solving problems with that representation or that model. So here's a situation where you've got a parabolic shape bridge, and so we've got this. Anchors that are 42 meters apart. The maximum height of the bridge is 26, and so find the equation that models the shape. So it doesn't actually have to ask you to do anything other than just find the equation. So some of these questions could ask you then to use it to sub in to find out, like, if a truck will fit through or something like that. So what we need to know is what form are we going to use? So do we want to use vertex form? Do we want to use factor form? Do we want to use standard form? So, like, what we know is we have the vertex. We don't necessarily have it at a coordinate, and so you can actually draw it anywhere you want. And so you can draw this. It might make sense to put the zeros at 0 and so that they're 42 meters apart. Or it might make sense to put the vertex at 0, 26 and then have 21 on both sides. It's kind of up to you. What you really need to know, though, is that A value. You don't have that stretch compression factor. And so how are we going to get there? Probably by starting with one of the expressions. Making sure that it works for the vertex form maybe is okay. So we could start with vertex form and plot your vertex. And so make sure you've drawn a piece of paper that has a quadratic with a maximum height of 26 and the zeros are 42 apart. How are you going to get there? We're going to solve for the a value by subbing in a point. So the a value is going to work like a variable, but the points that are on your quadratic can then be used your x and y. And so it's really looking at the strategy. Like here's a situation where you can go a couple ways, set up the equation and sub in a point to solve for the a value. The a value is really what you're going to be looking for. The next one, we actually did this problem very similar before. So it's like the market research question. So what do we know? We know things like, we know that we're going to be making 56,000 riders for $2 like per ride. So that's actually a point on the graph. We could find the points on the graph where we have like 0 money, if we charge nothing, or if we charged, say $4, or like the most amount of money that we could charge. $0 is a good one because then you could find out, okay, how many times you have to drop the price to get $0. Then you're going to lose people. So those are all the things we know about the situation. We might want to sketch a graph just so that we can see what's happening. What do we need to know? We need to know the vertex. And so we'll probably have something like with zeros that doesn't have a vertex. And so we could then go and find the axis of symmetry and then use the axis of symmetry and to find the vertex. How are we going to get there? That's that strategy of actually using factored form to find the axis of symmetry to find the vertex. The next one here, what do we know? We know like the length is probably x, or sorry, the width is probably x or w. The length is bigger, so we could draw a rectangle. It makes a lot of sense too. And then we also know, like, we know that we can make an equation for area, which is length times width. We know that there's a point that will give you a 1450, and so we don't know like what those widths and lengths are and to get 1450, but that's what we're looking for. So what do we need to know are the length and widths that give you 1450. So this is how we're going to get there. This is the skill of being able to find the roots of a quadratic. So when a quadratic doesn't equal a number. And so that almost always requires standard form. And so if you start with something in factored form, length times width, then you can put it in factored form, then expand it to standard form. And the key to get roots is to find 0 equals. So that's how we're going to get there is set up 0 equals a quadratic and either factor or use a quadratic formula. And potentially there's only going to be one answer that'll make sense because it is a rectangle. Area given a perimeter, and so we've got a situation here where it's very similar, except you don't have the length and the width. You just have that like you can call them W and L or X and Y, but we just know that like 2 of them plus 2x's plus 2y's equals 32.5. And that's actually going to be what allows you to set up your area. So you still have to find an equation for area. X could be the length, and then the width. We don't want to just call it W, but we could use the equation for perimeter then to set up an equation for W, so that we have like a function for quadratics that only has like one input. So it only has like length or width. And then what do we need to know? So we want to know that the maximum rectangle is actually a square. How are we going to get there? We could find the vertex. So we've got something in factored form. Factored form can give you zeros. You can get the vertex by using the axis of symmetry. This is an interesting question. It's sort of dated with Bautista. But here's a situation where you've got baseball, and so like things that we know are the balls hit over home plate. So it's I'd probably call it 0, 3.5. So your y-intercept is 3.5. We know that the ball hit a maximum. We know that we've got the vertex. We probably have to find the equation, because you're just given a point that to really test the equation out from. So you don't know if like the ball is going to be 15 feet high at 328 or not, or if it's going to be over or under. But we know that if we subbed in 328 to the equation and you got a number higher than 15, then it would hit a home run. And so what you need to know is like the equation. And so you've got a y-intercept and you have a vertex. And so here, like the strategy we're going to use is that same strategy of solving for an a value. So the same strategy we use with the arch. And so the big thing here is we're going to find an a value. And again, like this is kind of hard to follow but it's just important to like start thinking about a plan from like how are you going to attack questions. And so before you start those questions and realize that like for this one, I need an equation. And if I had the equation, I could then sub in one of the numbers. A lot of people see this one and then they sub in 328 and 15. We don't know 15 is the height. We just know that the ball, if the ball is a negative height at 328, then it doesn't even hit 328. But we know that we can test out where the ball is going to be at 328. Last one, what do we know? So we know that the pool is inside a yard, and uniform width means like you've got a deck around a pool. The total area, so the bigger area, is 12 by 16. We know that the pool is half of that, so like 12 by 16 divided by 2, or 96. And so what we can do is to find the dimensions of the yard, like an equation for the dimensions of the pool, knowing that the pool is going to be 96. But if we could set up an equation for the pool, and we could actually find the dimensions that are just similar dimensions to the 12 by 16. Now there's one easy way to do this question and just kind of have it in the same proportions, just taking it off and finding out like kind of guessing, checking. But this is a situation where you've got like a rectangle, but it's not like the rectangle, like the function for the pool is still length times width, but it's not 12 by 16. It's like 2x less than 12 and 2x less than 16. So if you set up the equation, then you could solve that equation for 96. And so this is a situation where you've got a factored form equals a number. So you're trying to find the roots of a quadratic. So again, you're going to need standard form so that you can use the quadratic formula, or you can refactor it to get the answers. And so that's how we're going to get there, is the same strategy of finding when a function equals a number that's not 0. Okay? And so here you're just kind of looking, and this one's a little bit trickier than the last one. You're just really looking at like, what's the strategy you're going to take? Like, can you just wrap your head around what you would do rather than like kind of get caught up in the steps of actually